Hello, my name is Mike crAPI, and today we're going to talk about why AI security is dependent on your API security. APIs are the foundation of how automation through MCP servers and AI and APIs all work together. If your APIs are insecure, your AI infrastructure is going to be insecure. One of the stats we should take a look at here that should jump out at you is 42%. 42% of security incidents, not just API incidents, security incidents in general, are now linked to APIs powering AI applications such as models and agents. So today I'm going to do a demo. I'm going to show you why it is you are going to want to interface AI with your application platforms, how it's a benefit, but I'm also going to show you how it could be a very detrimental effect on security in your organization if your APIs that lie underneath the AI are not secure. So coming over here, the first thing I want to bring up is in our Akamai API solution, we provide the ability to detect when MCP servers are in use working with your API applications. You can see here, if I just click, come in here and take a look at my basic inventory, we see we do handle quite a bit of sensitive information, PCI data. This is a summary screen. And if I come under here, you can see I have a lot of APIs. And that's one of the things we do. We discover those APIs so that you can see what's working in your organization, because you can't protect what you can't see. But more importantly is I talk to security CISOs and leaders, and when I ask them, where are you on your AI journey? And are you interfacing AI with your APIs, with your applications? And a lot of times the answer is we don't know. Coming here, you can see here, if I just choose a built-in filter that tells me what APIs are working with MCP servers. In other words, what APIs are using AI to interface with my applications. I get a list here. I can see all the different MCP tools, a lot of different endpoints. Now, why is this important? Well, if you're a security admin and you don't have a handle on whether this is in use or not in use, you can't really work with the developers to come up with a policy for something that you don't even know is working. Now, why would your developers even want to have your applications, your APIs talking to a large language model? What benefit does that have? Well, if I come over here and look at my application, I come in here, I log into my dashboard. Now, this is a sample application. It's called crAPI, stands for Completely Ridiculous API. Now think of this maybe as one of those mobile apps you use to start your car, find your car, see the location. This is what this sample application is going to simulate here. And it is designed to be vulnerable in some cases. Unfortunately, many cases, we do find customers that have the same vulnerabilities in their production apps that this application has, and that I'm going to demonstrate to you. Now, I don't know if you've ever navigated, like Best Buy, Amazon, or any of these pages. Sometimes it's hard to drill down and find what you're looking for. What the AI does is it makes it possible to interact with this application without having to know where to find things in the menus. Since it's want to buy products, return them, post a community forum, and so on. For instance, if I say, get my recent orders, I can just say it in plain English conversational language, and the AI is going to go talk to the backend APIs, and it's going to figure out how to get those orders. So here we go. We have the orders. If I want to buy me a new seat, it will go ahead and do that. Obviously, this is a sample application. In Amazon, you have your put in cart, checkout, and all those things. But now it's giving me my remaining credit balance. It just ordered a seat for me. Now, what happens if my teenager comes out, they just got their driver's license, they're going to a movie. I want to trust them, but I'm going to verify. So you can see here, I have my location here, but let's just say, where is my car? Show me on a map. I can just plain conversation, and keep in mind, nowadays with AI, you could actually talk to the application. You can actually talk to your APIs if you want to use the voice option as well. And right here we see, there is my car. That is the good of using an large language model, talking to your APIs through an MCP server. And this is an example. These are some of the endpoints we are talking to when, in this case, my Claude desktop client makes these calls. Now, what are the negatives? Well, depending on how your APIs are they written properly? Are they secure? If I go in here and I say, give me the location of all users and show on a map. And the AI is going to go in there and it's going to figure out, what I got to do. It's going to see the APIs. It's going to see, well, what do I need to get the location? And it's going to figure that out and plot everything for us on a map. And as you can see here, this can be a little creepy. I can see everybody's location. Very nice to show my car location. Very handy. Not so handy if other people can see where my car is at any given time. And keep in mind, this could be an app, working with medical records, could be anything. Now you're probably thinking, well, just get rid of the MCP server. That'll fix everything. No, it won't. And we've had customers, when they hear problems like this, they kind of panic and they say, hey, let's put API security in the back burner. We got to look at our AI security. Not thinking that if our APIs are secure, that will solve the problem. And in this case, it is the APIs that's the underlying problem. And I'm going to prove it to you. I don't need AI to figure these problems out. If I just come into my crAPI app, I'm going to very quickly show you what is the basis of the problem. And these are using very easy to use tools. In fact, this is nothing more than the tools built into the Chrome browser. This is just Chrome. I am just using what's built in. I do a right click and inspect, and now I can bring up the APIs. And if I come into the response of the various APIs responses, you can see there's a lot of data here. Take a look at the page though. There's more data being returned than what needs to be displayed. Number one, why would that be? Well, back-end developers, honestly, sometimes they just can be maybe lazy, call it what you want. They just say, hey, rather than try to customize all these responses, just give them all the data, let the developers figure out what to display, whether it be their mobile app or their web browser. The problem is that's not secure. Any user can come in and see, okay, what did the API actually return that the browser didn't show? And in this case, you can see here, this is the vehicle ID. And it's very cryptic. This is not something that someone's going to randomly guess. And if I come in here and I do a refresh location, we can see there's my vehicle ID, but let's look at the header. This is what is sent to the backend server. You can see my vehicle ID is part of the URL. This is how I figure out where my car is. If I come in here and I go ahead and paste that, I do have my authorization, my authentication token. And if I'm a hacker, I know I can get that from here. This is my authentication token. This has been placed into Postman, which is a free application for developers. And if I send that, I get my vehicle location. Fair enough. What happens if I come in here under community and I come in here under response and I look and I try to find some random, let's grab some random user's vehicle ID, which I should not even be able to see because I should not be returning this. This is data that you just do not need for posting anything in the form. This is not something the user needs. But if I come in here and I just replace that and hit send, voila, I have Adam's vehicle location. I have their longitude and latitude. This was done with no AI, and this is something that anybody that knows what they're doing is going to be able to figure out. All the MCP server did was make it easy for me to do it, much easier. So the problem isn't getting rid of the MCP server. That would definitely be maybe security by obscurity, a little bit of a deterrent, but this isn't the problem. The problem is your APIs are not written correctly. And if I come in here, this is what's called the OWASP API Top 10. What issues did we see? Well, coming into here, you see this number 3, excessive data exposure. When I'm showing data that I don't need to be displayed in the web browser, that's a security problem. That's number 3 on the OWASP API Top 10. The number 2 attack was BOLA, broken object level authentication. Why did this happen? Because I'm only authenticating the user. I am not checking ownership, whether the user is supposed to be able to see the information. You need an API security solution that can alert you to these problems. For instance, if I come under here in my API security solution, Akamai API security solution, I can see that I am alerting you to when you're returning information that shouldn't be. In this case, I'm returning an API, an email address that is being done without any authentication. So it's alerting to you, telling you what compliance frameworks it violates. So number 1, in that case, you're going to want to go to developers and tell them, number 1, you're returning too much information. That's OWASP API Top 10, number 3. Number 1, the number 1 issue with your application is you're not checking proper authorization. And you're also going to need to be alerted at that. Like right here, if I come in my runtime event, I can see right here that I have a problem where a user successfully accessed 4 resources while a typical user accesses 1, for example. This is that BOLA attack. This is an example of a BOLA attack that we just seen my AI exploit, and then later I exploit with Postman. The way you fix that is you do proper authorization. Just like when you log into your Active Directory at work, you cannot change anyone's password. Only the administrator is authorized to do that. And this is something that a WAF or API gateway doesn't do. They do not learn the behavior and intent of your application. Notice the verbiage. Access 4 resources while a typical user only accesses 1. This is behavioral learning. What you want to see here is the user unsuccessfully attempted to access 4 resources while a typical user accesses 1. That is a situation that shows that your application is not allowing it, and we are seeing the BOLA attack, but our application is smart enough to know not to allow it. Now, thank you for watching. One thing I want to point out is that I do have this application, the MCP server, if you want to do this application on your own time, in your own lab. crAPI is a publicly available application. I have instructions on how to install it, get the MCP server up and running. Please reach out to me at either one of my social media contacts or mcropsy@akamai.com. You can also check out the Akamai 2026 impact study, which goes through some of the stats that I showed early on in the presentation. Again, thank you for watching, and again, feel free to reach out. Thank you.